Hello everyone, my name is Shyam Chauhan and today we are going to discuss topic number 2.2 Geometrical meaning of zeros of the polynomial. We have discussed the polynomial which can be represented by p of x where x is variable. Then we know that zeros of polynomial can be found by using p of x equals to 0 and we will find corresponding x. To represent the zeros of the polynomial geometrically, that is using the graph, if we are given with, suppose say example, p of x equals to 2x plus 4, to represent this on the x and y axis, that is on the graph, we find the y, that is we put p of x equals to y equals to 2x plus 4. Then we plot the x and y coordinates, that is first we put x equals to 0 and we find the y, that is if we put y equals to 2x plus 4, if we put x equals to 0 you will get corresponding y, that is equals to 4. Then we put y equals to 0 and we find corresponding x. We put y equals to 0 and find corresponding x, that is 2x plus 4 minus 4 equals to 2x, and we get x equals to minus 4 by 2 equals to minus 2. And then we plot the curve, that is for x equals to 0 we get y equals to 4 and for y equals to 0 we get x equals to minus 2, and we plot the curve. Now for zeros of the polynomial, we put p of x equals to 0. That means we can replace p of x by y. That means for zeros of the polynomial, we have to find the curve points where y equals to 0. For the points where y equals to 0 is the x-axis. The x-axis has y equals to 0. So in this case there is only one point where y equals to 0. And the corresponding x is minus 2. So to find zeros of polynomial, plot the curve and the number of points where y equals to 0 are the zeros of polynomial. So let us check the theory, that is geometrical meaning of zeros of the polynomial. We put p of k equals to 0 for the zeros of polynomial. To find zeros of polynomial, we put p of x equals to 0, and to represent the curve, we find the x and y. For x equals to 0, y equals to 3, and for y equals to 0, x equals to minus 3 by 2, and then we plot the curve. In this case, curve is a line, and the points where curve touches x-axis are the zeros of polynomial. That is, at the point minus 3 by 2 comma 0, zeros of the polynomial is minus 3 by 2. That means this point is the zeros of polynomial 2x plus 3. In general, for linear polynomial, that is of the form ax plus b, the graph y equals to ax plus b is a straight line and intersect the x-axis at only one point. That means we can write, for linear polynomial, so for linear polynomial that is of the form y equals to p of x equals to ax plus b, the curve is straight line and intersect x-axis at only one point. So for linear polynomial, p of x equals to ax plus b has only one zero of polynomial. Now for quadratic polynomial, that is of the form ax square plus bx plus c, the corresponding graph will be the parabola, either open upwards or open downwards, whether a equals to greater than 0 or a is less than 0. So for quadratic polynomial, we have equation p of x equals to ax square plus bx plus c, and has two types of curve. Curve upwards, that is of the form this. If a is greater than 0. If a is less than 0, then curve open downwards, that is of the form and the curve is called parabola. The curve is called parabola. For this equation, that is y equals to x square minus 3x plus 4, ax square plus bx plus c, a is 1, so a is greater than 0, that means the curve open upwards. It is of the form that is open upwards. And the quadratic polynomial has 3 cases. Case 1, polynomial p of x has two zeros of polynomial. That is, if we put p of x equals to 0, we will get x equals to x1 comma x2, and if we plot the curve, we will get the curve that touches the x-axis at two different points, that is at x1 and x2, and these are the two zeros of polynomial. Then case 2, only one zeros of polynomial, that is, if we put p of x equals to 0, we get x equals to both the similar root, that is x1 comma x1, and if we plot the curve, it intersect the x-axis at only one point, that is at x1, which is the zero of polynomial. In third case, case 3, where there are no zeros of polynomial. That means the curve does not intersect the x-axis, it is either above or below the x-axis. We have seen all the cases, that is case 1. There are two zeros of polynomial a and a dash, and curve intersect the x-axis at two different points, and where the curve intersect at x-axis is called the zeros of polynomial. Here also it intersect at two different points. Curve either open downwards or open upwards. It open upwards where a is greater than 0 in ax square plus bx plus c, and it opens downwards for points where a is less than 0, and these two are the zeros of polynomial, where a and a dash. P of x equals to ax square plus c. Case 2, where it intersect at only one point and has only one zeros of polynomial. A and a dash, that is two zeros coincide at x-axis. And case 3, that is curve either completely above x-axis or completely below x-axis, and it has no zeros of polynomial. When the curve intersect x-axis, that are the zeros of polynomial, but the curve does not intersect x-axis, hence there are no zeros of polynomial. This is the curve, and this does not intersect x-axis, hence there are no zeros of polynomial. No zeros in this case. So for quadratic polynomial, either it has two zeros of polynomial, or there are two equal zeros, that is one zero of polynomial, or there are no zeros of polynomial. If we write here, for quadratic polynomial, number of zeros are either 2 or 1, or there are no zeros of polynomial. Now for cubic polynomial, that is of the form ax cube plus bx square plus cx plus d equals to 0. For cubic polynomial, p of x equals to ax cube plus bx square plus cx plus d has either 3, 2, 1 or 0 number of zeros of polynomial. We have number of zeros of polynomial that are 3 or 2 or 1 or 0, zeros of polynomial. That means if we put p of x equals to 0, we will get either 3, 2, 1 or 0 zeros of polynomial. If we see the graph of cubic polynomial, it intersects x-axis at 3 distinct points. It has 3 zeros of polynomial. Then it intersects the x-axis at one distinct point, and the third case, that is, it intersects the x-axis at two distinct points. There is a remark that in general, for p of x with degree n, y equals to p of x intersect x-axis at most n point. Therefore, the polynomial p of x of degree n has at most n zeros of polynomial. So, for polynomial p of x of degree n has at most n zero of polynomial, and because it has at most n zeros of polynomial, the curve intersect x-axis at most n points. If we write that p of x equals to ax raised to n plus bx raised to n minus 1 plus cx raised to n minus 2 up to k, it has the degree n. So, number of zeros of polynomial possible are 0, 1, 2, 3 up to n. Now the example 1. Example 1 says that look at the graph in figure 2.9. Each graph of y equals to p of x, where p of x is polynomial, we have to find the number of zeros of polynomial. So for first graph, it intersects the x-axis at one point, so number of zeros is 1. For second graph, it intersects at 2 points at x-axis, so there are 2 zeros of polynomial. For third case, it intersects at 3 different points at x-axis, so there are 3 zeros of polynomial. For fourth case, it intersects the x-axis at only 1 point, so it has only 1 zeros of polynomial. For fifth case, it intersects at 1 point, so 1 zeros of polynomial. And for last, it intersects at 1, 2, 3 and 4 points, so it has 4 zeros of polynomial. If we see the solution, that is for first 1, 2 and 3, Number of point on curve of polynomial p of x where it intersect x-axis, or we can say the points where y equals to 0. Points where y equals to 0 are the number of zeros of polynomial. We have seen all the solution, that is for fourth case 1, 1 and 4, that is 1, 1 and 4 zeros of polynomial. In next lecture we will cover exercise 2.1. Thank you.